Hi guys, in this video I'm gonna go through this Leetcode number 55 jump game, and we are given an array of numbers in here, and so we initially standing here, and each element in the array represent how many steps of jumps, maximum number of jumps at that position, and we need to return a true if we can reach to the last index, otherwise returns a false. So, for example, it looks like this. Another example looks like this. So, at this point, we can jump 2 steps. So we can jump to here or here. And when we are here, we can jump 3 steps. So either here, here, or here. And if we jump to here, basically the game finishes. And for this, so that's why we turn the true, because we can go to the last index. And for this example, there's no way to jump to the last index, because if we're here, the maximum we can do is jump 3 steps ahead. So we will end up here. And for this guy, the maximum we can do, the best we can do is jump 2 steps ahead. So we'll be here. And when you jump to the 0 position, there's no way to jump out again, because there's no steps that we can jump. There's no jump length for this position. And for here, the best we can do is jump to here, which is like a prison, right? Not like a prison. Sorry about that. It's like absorbing position. You jump in it like a black hole, and there's no way to come out. Yeah, black hole is a better way to describe it. So some visual inspection. So for example, when you are here, you can jump 2 steps, or here and here. When you jump here, you can jump 3 steps, and here, here, and here. So in this case, you can reach to the end. And when we are here, and go to here, that's the best we can do. And yeah, here we can jump to here, here, let's jump here. When you jump into this hole, there's no way to come out again. However, if we increase the length by 1, so when they are here, we jump all the way here, because there are 4 steps maximum length. So we can jump 1, 2, 3, 4, and jump to here. For example, here we jump 3 steps. 1, 2, 3. When you are here, we jump 2 steps, and we jump here. The game finishes. So a way to do it, one approach to do it is use dynamic programming, because we can decompose this big problem with many sub problems. For example, when we are here and we take 1 step ahead when we are here, so basically the problem becomes we only need to consider this many numbers ahead of us. So we jump out of it already. Or if we jump 2 steps, and the problem becomes from the bigger problem looks like this, and now it becomes a smaller problem looks like this. So we can solve it by using a recursion or a dynamic programming. And let me show you how we can do that potentially. So we have a memorization dictionary that keep track of how many steps. This memorization dictionary keep track of whether we can jump to the end when we are at the ith position. Initially it's false, because we haven't filled out this dictionary yet. The reason why I use dictionary, because it's fast. It's constant look at time is big over 1, and then we basically just do what we just said. Constantly move forward, and then fill out the dictionary. And yeah, so that's the code. But I must tell you that this is not going to work for this Leetcode system, because it's going to time out. It takes too much time. And what will work is to use a greedy approach. So what a greedy approach does is, when we are at the end, we are asking. So our goal position is reach to the end. However, if the one before it, the step is greater than or equal to 1, we can jump to here. And that means we move the goal point, the end point, to here. And when we are here, basically, if we can jump from one step from the prior, and then we can move the goal endpoint to here. So you see what I'm doing? I'm just constantly moving backward for the goal endpoint. If the goal endpoint is here, that means we can reach to the end for sure. And for another example, the goal endpoint is here, and when we move one step back, there's no way to jump here, so the goal endpoint cannot be here. And also, when we are here, we can only jump one step ahead, so the goal endpoint and cannot reach to this guy over here. There's no connection between this guy and this guy because it's too low. It's not high enough. And the same thing here, same thing here. That's why from the beginning, there's no way to jump to the end. So we use a greedy approach to move the goal endpoint one step in backward. Another example in here, the goal endpoint is right here, and when we move one step back, when we are in the hole, there's no way to jump out. That's why this one cannot be the new goal endpoint. However, the new goal endpoint can be here because we can jump 2 steps, 1 and 2. And when we are here, and there's a connection between this point and that point, that's why this one can be the new goal endpoint. And then because there's a connection between this one and this one, so this one can be the new goal endpoint. Same for this. When we move to the index 0, we basically are sure that we can jump from the beginning to the end. So the code itself is pretty simple. We have the initial goal endpoint, the target endpoint at the last index, and then we move backward to index 0 by using its range from the last index to the beginning index, excluding this guy. So its beginning index will be 0. And if we can build connection, if the number of jumps we can do is greater than the distance between the current endpoint and the position that we are at, if that the jump distance is greater than the distance, and then we can reassign the new endpoint. And at the end, if we check if the new endpoint is the current endpoint, is it equal to the 0 index? If it is, we return a yes. Otherwise, we return a no. And this algorithm is pretty efficient, as you can see. So this is how we can solve this problem, jump game, by using 2 approaches. One is the dynamic programming, which does not work because it's too time consuming, and then this one, the greedy approach, takes a big over n time, and the space complexity, just we need one variable to keep track of the current endpoint, so it's big over 1. Yeah, this is my solution. I hope you like it. If you do, please like this video and consider to subscribe to the channel, and I will see you in the next video. Thank you for watching. Bye bye.